In this lecture series, we will learn about the basics of the STAAD Pro software and its graphical user interface. That is, all the options that are available on the STAAD Pro screen. So first of all, we will start with the project task. Here you have an option that if you want to go for a new project. Second option is that if you want to open some old working project or open from project wise, here you can see the recent files that I have worked upon, and the thing that on this screen that is very important is this configuration option. So configuration allows you to go for the current default base units, that is whether you want to go for English units or whether we want to go for metric units. So in this lecture series we will go ahead with both metric as well as in English units, but right now select metric units only. After that, we can see the section profile tables that are available in the software. So here you can see that American, Australian, Brazilian, British, Canadian, Chinese, Dutch, all of these are arranged alphabetically for your consideration. And here you can see that in addition to the rolled steel tables that are hot rolled steel, we have cold formed steel tables also. That is Australian, British, European, Russian, Indian, Japanese and American. And joists that are used in the American design, so only American steel joist table is available, aluminium only American is available, and for timber American as well as Canadian is available. So for timber design we can go ahead with either American code of design, we can go for Canadian code of design, that is CSA, or we can go ahead with Euro code of designs. So for timber designing only 3 codes are available. So right now we can select as per your country. So right now we can either go ahead with American only, or if you want to go ahead with some other option also, you can go ahead with that. And it is not like if you select American here, only American will be available inside. All of the sections will be available inside, but the thing is that whatever you will select here will be available first. So after that we can select the global access orientation also. So for those who are comfortable with Z up, they can select the Z up option, or as I am comfortable with Y up option, so I will select Y up only. And here the default design codes available. So like we have selected the section profile table default as American, we can also select the default design codes. Again I repeat, it is not like if we select for example BS5400, BS5400 will be available only inside. All of the design codes that are available here will be available depending upon the license you have. So for default steel design code we can go ahead with AISC 36010. Default concrete design code we can go ahead with ACI 318 2011. Although ACI 318 2014 is the latest version, but it is available in the most recent versions of the STAAD Pro software, that is STAAD Pro Connect version. After that, aluminium only US design code is available. For timber, as I was discussing with you earlier, AITC that is American code, EC5 that is Euro code, and CSA that is Canadian code. So these 3 country codes are available for timber design codes. I repeat again, these options are available depending upon your license only. So maybe if you have Eurocode version license, then only maybe this Eurocode version option will be available in your software. And after that, default shear wall design codes, that is either ACI or BS or IS 456. So we can go ahead with ACI only. So we have selected all the options with as the American version options. After that we can select background color also, that is either we can go ahead with white background, or for those persons who are comfortable with the black background or which have some history of working in SAP 2000 software or ETAP software, they might go ahead with black background, but I am comfortable with white, so I am selecting this option only. And after that let's click on apply and accept. So this forms the basis of the working in the software. One more thing that I had like to point here, that there is this option, legacy STAAD editor. See, after STAAD Pro SS4 version, or I think SS3 version, they have inputted a new version of STAAD editor, which although is very helpful in the terms of editing or in the terms of inputting the data, but the new version of STAAD editor is somewhat heavy, and in slow laptops or in slow personal computers, and the new STAAD editor might lag. So I am comfortable with legacy STAAD editor only, and I will advise you to go with legacy STAAD editor only. New STAAD editor might look like fancy or might look somewhat new, but it is not desirable to go with that version, especially if you are working with very heavy STAAD files or very heavy structures. So I will advise you to go with legacy STAAD editor only. Left click on apply and accept. So here you can see the recent files that I have been working upon. So right now I will go ahead with new project option. So here you can see that space, plane, floor and truss option is available, and the definition was for space structure is given, that is 3-dimensional frame structure with load applied in any plane is the most general. So all those three RCC framed buildings, or all those steel framed buildings or aluminium framed buildings or timber framed buildings, whatever you have been working upon in space shall be selected with this option only. Planes shall be selected if you are doing a planar analysis, that is bound by global X and Y coordinate only. Floor is a 2-dimensional or 3-dimensional structure having no horizontal movement of the structure. So floor is used only for the floor analysis, and truss is also a widely used option. So if you are modeling a truss in the STAAD Pro software, if you will select this truss option, the software will make sure that only axial forces will flow in the structure. And moreover, if you will assign or you will model a truss in a space structure with idealized supporting system, it will show the instability, and plus it will show the some minor or major axis bending moment also in the truss. So if you are modeling a truss structure, idealized truss structure, I will advise you to go ahead with truss only. That we will go do in the examples also. But right now, to make things simple or just as an introduction, we will go ahead with space only. After that, we can select the location where we want to save this STAAD file. And one more thing that I had like to add here, that you can also add the name of the folder. For example, you don't need to left click here and name the, or like right click and select the new folder option. You can just name the folder here, and STAAD Pro will automatically make a folder there. So we name it as a tutorial 1 option. After that, length units. So whatever you are comfortable with, I am comfortable with the meter and kilonewton option only. So I will select meter and kilonewton, and also this option is by default available because we have selected metric version in the configuration option, that is here. So left click on next. That is specified part does not exist because we have named a folder here as tutorial 1. So in this folder location, it will create a new folder. After that, again it is showing various options, that is add beam, that is begin building your model by creating new joints and beams. Most of the newbies click on this add beam option. Add plate, that is if we want to do the plate analysis of 3-noded or 4-noded plate. If we want to go ahead with FEM analysis of a solid. Structure wizard is by default some structures, ready-made structures are available in which you don't need to do the modeling. You just need to input the data, and after that, this is the most widely used option by me at least, that is open STAAD editor. And after that, you can left click on edit job information. So I will advise you to first of all go ahead with open STAAD editor option only, or we can go ahead with open structure wizard also. So to make the thing simplified, we can go ahead with open structure wizard. Left click on finish. So here, as I was discussing with you earlier, that is some ready-made structures are available. So here we can go ahead with truss models, frame models, surface or plate models, solid models, composite, that is bunker or silo, or we can go ahead with importing CAD files, that is DXF files, or we can also go ahead with VB programming. So to make the thing simplified, we can go ahead with frame models. Left click on grid frame. You need to double click on this option. So we can name the model as grid frame. Length can be 12 meter. Height can be, let us say, 20 meters. Width can be, let us say, 15 meters. So number of bays along length, that is, we can make it as 2. Number of bays means the distributions. So number of bays along height, that is the number of floors. So we can go ahead with 4 only. And number of bays along width, we can select it as 3. So left click on apply. So here we can see that you can rotate it in a 3D view also. That is, this height is 20. So as we have selected the number of bays along this axis as 3, the number of bays along this axis is 2, and we have selected the number of floors as 1, 2, 3, 4 and 5. So we need to save this and you can close this option. So would you like to transfer or merge this prototype into STAAD Pro? You need to select yes, and after that it will ask the options, that is on what coordinate you want to import that grid frame model. So we can import it into on the origin only. So we need to left click on OK. So here we have imported a simple grid frame model here, and here we can check that the model is imported on the origin only, that is x0, y0 and z0. So to make a simple RCC structure, what we need to do here is that we need to left click on view from +Z, select the beams cursor, which is by default selected always. You need to draw a rectangle here. You need to click delete option on your keyboard. So left click on OK. So here we can see that we have drawn a simple RCC frame structure, or we can see the steel frame structure depending upon the material we will assign to this. So the purpose of this tutorial is to make you familiar with the whole functioning of the STAAD Pro software. That is, it is just like a refresher course. If you know the software, it is well and good, but if you don't know the software, this tutorial is just in an introduction to what we will learn in the next various lectures. So first of all, you will see a lot of options here, that is file, edit, view, tools, select, geometry, commands, analyze, mode, Bentley Cloud Services, window and help. So file option is like if you want to make a new model, if you want to open an existing project, or if you want to view the input command file, or if you want to print, or if you want to import and export, or if you want to save. So these are just the basic options that we can see here. And again, these options are available here also, that is new structure, open structure, close structure and save structure. So all these options are available here also. Similarly, if we left click on edit, so it is like undo delete beam. All the beams that we have deleted, we can left click on undo delete beam. So we can see that one beam has came back. So we left click on edit and again redo. So after that we can left click on view. So view option is best served by these 1, 2, 3, 4, 5, 6 and 7 options, and this 8th option also. So what basically all these squares denote, if we look closely here, you will see that it is showing view from +Z. That is, if we see the local axis, or sorry, global axis here, you will see that this is the X global axis, this is the Z global axis, and this is the Y global axis. As in the configuration window in the earlier option, we have selected Y up, so that is why it is showing as Y up. And one more thing that I had like to add here, that in STAAD there are two axes, One is the global axis, and second thing is the local axis. So you don't need to confuse this global and local axis. Global axis means the one that is being shown here on the bottom left part. Always make sure that this is the global axis. Never say this is the local axis. About local axis we will discuss in the separate lecture. So coming back here, that is view from plus Z. That is, if we are watching a frame from this side, so this is the view from plus Z. This is the view from minus Z. It shall be same with the plus Z only. And view from minus X, that is from this side. So if we will see here, that is, if you see from this side, this is the view from plus X, and this is the view from minus X, and this is view from top, that is view from plus Y. So if we want to see a frame or a structure model from top to bottom, so we need to left click here, and this is the isometric view. That is, at any stage, if we want to see the whole structure in a comfortable manner, or if we want to see all the structure along both X, Y and Z axis, so we need to left click on isometric view. And this is the savior part. For example, what happens is that when we zoom here, you will see that isometric view is not displaying the whole structure. So either we need to zoom back, or we need to press scroll wheel again and again to zoom out, or we need to left click on display whole structure. So with this option, what basically happens is that it doesn't matter on which view you are watching the structure, or wherever you are, it will just display the whole structure on the original scale and on the comfortable scale. So now we are familiar with all these options of viewing from plus X, minus X, plus Y, minus Y, and plus Z, and minus Z, and isometric. And this I'm telling you again, this is the option that is also widely used by me. That is, whenever I am stuck in some view, I left click on display whole structure. Or what basically happens sometimes, for example, if we left click here on view from plus Z, we draw a rectangle here, we left click on view, and left click on view selected objects only, and then we left click on isometric view. So here you can see that we have drawn, or we are watching a particular floor level. But what if we want to display the whole structure again? This option will not help you, or neither of these options. This is the option that will help you. So with this option, if whenever we are stuck in some view, or whenever you're watching some view, we want to display the whole structure again, this is the option that will come to your save. So after that, we can study these options also. That is rotating option: rotate up, rotate down, rotate left, rotate right, or spin left, or spin right. And this is also a very helpful option, that is toggle view rotation mode. So when you left click on this option, a small circle with lines will be available here. That is, this is the point about which your structure will rotate. So when we left click here, that is either rotate left, you will see that the whole structure is not rotating about like central axis. The whole structure is rotating about this point only, or whatever we will select the option. So whatever the rotation is being done, it will be done about this point only. But what if we want to rotate, let us say, about this point? So what we need to do is that we need to left click on Control Shift and select node cursor here. So here we can see that the rotation mode is now about this point. I repeat the action that I had done. Press Ctrl plus Shift on your keyboard, both axes at one time, and select the nodes cursor here and press the left click here. So here we can see that now if we rotate the structure, it will be rotating about this point only. So if we want to switch off that option, we can just left click here. So now we have studied all these options, that is view from various planes and rotating option and display whole structure option. Now what if you want to zoom in and out? So to zoom in and out, either we can repeatedly rotate the scroll wheel on your mouse, or what we can do is that we can either press dynamic zoom. This is the option like this. So what basically happens is that when we left click on dynamic zoom option here, if for example if we want to view this junction, here you will see that all these options are closed, that is we cannot go back. So what basically happens is that the software has opened a new window for your consideration. So if we want to close this option, you need to press close here, so it comes back. After that, it zoom extent option, that is if we, for example, if we are in this plane, so again this option and this option is somewhat same. After that, if we want to zoom in, we can use this option, zoom out this option. Or what if you want to zoom the structure 5 times or 10 times? So for that option, it is zoom factor option is available here. You can go for let us say 10 times. So this structure is now zoomed 10 times. So either we can display zoom extent or display whole structure back, or we can go ahead with zoom previous options, or we can go with zoom window option also. So all these options of zoom you can practice by your own. And after that, this is the pan option, that is almost available in all the software. For example, it is available in the ETABS also, it is available in the AutoCAD also. This is a magnifying glass. This is a somewhat funny option. For example, if we left click here and then left click here, so here you can see that it is showing it as the like magnifying glass, and after that it is a 3D rendered view. So when we left click here, it will open a new window for us and it will show the 3D rendered view. At any stage, if you are stuck like this, so the simple thumb rule is that if these options are not available to you, then this is not the original modeling window. So you need to close this window here to come back to the original modeling window. So we have studied this whole toolbar of viewing from various planes, of rotating the structure, of displaying the structure, and zooming the structure. So in the next lecture, we will learn about these options. So in the previous lecture, we have learned how to draw a basic model. What are the options that are available on the STAAD Pro graphical user interface, that is GUI. Here we have already studied the view option, rotate option, display whole structure option, and zoom options, and 3D rendered view option. Now we have also discussed about this options and undo redo option. So here you can see the print options, that is either we can go ahead with print preview, report setup, take picture, export view. Or for example, if you want to take a picture of this model, what we need to do is that we need to left click on export view, and it will save the image in a either BMP format or JPG format, or these formats. So we can go ahead with JPG format. We can put the file name, that is model image, and we can save it. So we can access this image also, and after that print current view or print preview current view. After that, it is showing the tables options, import units, and change graphical display units. So for tables, if we want to see, for example, the table for the nodes, so we left click on nodes and left click on OK. So here it is showing us that node number 1 is on x0, y0, and z0. That is, node number 1 has coordinates of 0, 0, and 0. Similarly, node number 2 has coordinates of 6 as x, y0, and z0. So similarly, it is showing us that the total 60 number of nodes are available in this model, and all the nodes have different coordinates. So we close this option here. So similarly, we can either select all the tables for our understanding. After that, it is also a very important option, that is input units. So at any stage of working in the STAAD Pro software, if we want to change the units, so let us say if we want to change it now into American units, that is foot and kilopound. So left click on OK. So if we left click on this option, that is display node to node distance, and left click here and then right click here, you will see that it is showing us the distance in foot, that is 19.685 foot. So similarly, we can left click on remove all node to node distance display. Again, left click on input units, select meter and kilonewton. Left click on OK. Again, select display node to node distance. Left click here and then right click here. So here we can see that now it is showing us in 6 meters. So it is up to us, that it is not necessary that if, for example, once we have entered the units on the welcome screen as metric units, you cannot change the units inside. You can also change the units inside from imperial to metric or whatever units you want to change. For example, if we want to see the distance in millimeter, so left click on OK, remove all node to node distance display and then left click here. So here it is showing the 6000 mm, that is 6 meters the distance in mm. So changing back to meter and kilonewton, left click on OK. So now we have understood what is the option of this, what is the use of this input units option, and these two, that is display node to node distance and remove all node to node distance display. For example, sometimes the dimension shown may hinder the view, or we may not be able to work properly when this distance is coming. So at any stage, if we want to remove all node to node distance, let's just left click here. Similarly, this is also option dimension. Basically what it does is that it display all the dimensions of all the beams. So left click on display and dimension to view and left click on display. So here we can see that all the dimensions are being displayed here in the meter. Similarly, if you want to remove here, just left click on remove and then close. So now we have understood these options also. And similarly, there is this option change graphical display units. So at any stage, if we want to change, for example, node labels, beam labels, plate labels, solid labels, or structure units. So for example, if we are seeing the results and if we want to see the displacement in inches, so here we can select the displacement and we can also select the precision of that distance. For example, if you want to see the show 4 decimal places, 3 decimal places, etc. So left click on cancel to let the units be by default, that is metric units only. And this is the option to scale. So we can scale the force units, we can change the labels, scales, loads and results and structures. So under this option, this is the window that is widely used while modeling. For example, at any stage, if we want to see the nodes on the structure, so we left click on node numbers, or we left click on node points and left click on apply. So here we can see that all the node points are highlighted here. So if we untick here and left click on apply, so all the nodes are now removed. There is one more thing that I had like to add here. That is, it is not necessary that you need to left click on scale and then again you need to left click on this labels option. What we can do is that just press shift and K option on your keyboard. So here we can see that by pressing shift plus K, all the nodes are now available. Basically, how we can check that what is the shortcut, we just need to left click on scale here and labels. Here we can see that K is written on the front of node points. So if at any stage, if we want to see the node points, we just need to press shift and K. At any stage, if we want to see the node numbers, we need to press shift plus N, or we need to open this graphical user interface option and then we need to check this option here. That is, all the node numbers are now available here. Similarly, we can select the beam numbers also. Left click on apply. That is, all the beam numbers are now written here. After that, beam orientation also. So initially in the previous lecture I was telling you that there are two types of access, that is global access and local access. So what we are seeing here is the global access. What we are seeing here is the local access. Here you can see that there are three colors available for each and every member, that is red, blue and green. It is red is for Y, blue is for X and green is for Z. That is the global axis and local axis are matching for this member. So it is not necessary that it is the same for all the structures or for all the members. So we will discuss in detail about this local axis in a separate lecture, but right now we untick this option here, and after that we can select the beam specifications, beam ends. Similarly, if we have plates in our model, we can select the plate numbers, plate orientation. Plate orientation is again the local axis of all the plates. After that, it is showing the properties, references, sections, surface numbers, show access at origin, material, master slave. So in front of each and every option you will find that there is a small bracket in which a letter is written. If we want to open at any stage at about any option, you just need to press shift and that particular letter. For example, if you want to see the load values in the structure, you need to press shift plus V. So initially these options might look difficult to you, but as we go on in the lectures, you will find that you will be familiar with all these options. So restricting myself to these options only, left click on close. And this is also a very widely used option, that is scale option here, or either we can right click here and then left click on labels to open this options, that is scales options. And design results options will be available only after we have modeled, analyzed and designed the structure. Force limits are also available here. Loads and results. So here you can see that compression is highlighted as red and tension is highlighted as blue. That we will also discuss in the separate lectures. So now we have studied about the scale options and insert text. Insert text is this option that I had never used in the STAAD. For example, it is just used to insert a particular text here. So after that, it is showing the property page, support page, specification page and load page. So basically there are two ways to access these properties, support, specification and load. Either we need to left click on this option, that is general and property, that is properties windows will open, or either we can left click here, just press close option here. You just need to left click here in property. So here we can see that properties window is now available. This property window is used to input the property of each and every frame elements, or either we can assign beta angle. Beta angle is also a very important concept while modeling, that we will discuss in the separate lecture. Similarly, the support option, that is can also be accessed here, So after that, this specifications page, so specifications can also be accessed from here, or it can be accessed from here. After that, loading page, that is all the loads and definitions can also be accessed from here, or it can be accessed from here also. So I am a person who is comfortable with these options. There are some engineers who are comfortable with these options. So it is all up to your practice that how you open this properties, supports, specifications and loading data. So after that, it is showing various type of modes. So it all depends upon the license that you have. And so now we have studied these options. Also we have studied these options, and here we can see that there are some options to add beams, add 4-noded plates, surfaces, solids and etc. So these options are also a very important part of modeling that we will discuss in the next lecture. But before that, I had like to add some points here. That is, might happen that you don't have the same toolbars available in your STAAD. So what we need to do here is that we need to left click on view and toolbars. So here you can see that, for example, this is the file toolbar, this is the project wise, this is the print toolbar, this is the structure toolbar, this is the view toolbar, rotate, mode, selection, geometry, generate, structure, results options. This is also very important toolbar, but we will use these options only in the post-processing mode. That is after we have modeled, analyzed and designed. Similarly, labels, steel design, building plane, building frame, etc. Also, it is showing that show tooltips. If we untick this option here, it will not show the preview of what exactly is the option useful for. For example, previously it was showing the scale, or it was showing as the properties option, but after we untick that option, it is not showing. So we left click on view and toolbars and again open the show tooltips option, and after that view cool look. That is, some old people might be familiar with these fonts, but we remain the option as it is and left click on OK. So now we can see that it is showing the preview, that is property page. So it's all up to how we have arranged these toolbars. So we can also move these toolbars. For example, let us say if we want to move these toolbars here, so we can move this toolbar here, and also like this. So it's all up to your comfort or your experience that how you want to arrange these toolbars. So in the previous lectures we have learned about all the options that are available here, but in this lecture I would like to move on to some very important options that are widely used, that is add beam. So this option is used to add beam. So before that, we can left click on this beams cursor option and left click here and then press on delete option on your keyboard. So if we want to add a beam from this point to this point again, we need to left click here, that is add beams, left click here and then again left click here. So now a beam number 134 is modeled from this node to this node. So again we can press escape key on your keyboard, or we can left beams cursor on the screen. So this is the option to add beams. After that, add 4 noded plates. See, plates are usually modeled for the FEM analysis only. So for example, if we want to model a raft foundation, or if you want to model a combined foundation in the STAAD software and do the FEM analysis of that, we need to model it as 4 noded plates. So to stimulate that, what we can do is that we can left click on view from plus Z, select all the beams here, left click on view and selected objects only, go to plan view and left click on add 4 noded plates. So we can left click here and then again left click here and then again left click here and then again left click here. So now a plate is modeled here between these 4 nodes. And if you want to see the number of nodes, we need to press Shift and N on your keyboard. So a plate is modeled from 49, 50, 52 and 53 number of nodes. And one more thing that we can do here is that we can press Shift and P option on your keyboard. So by pressing Shift plus P, you can check the plate number. So similarly, we can model a plate between these 4 nodes, and then again here, and then again here, 139 and 140. So we have modeled 6 different number of plates from plate number 135 to plate number 140. And if we want to select these plates, we cannot select these plates by this beams cursor option. We can select only beams. So what we can do is that we need to select plates cursor option here, and then after that we can select these plates. So now we have 6 number of plates. So this is the option to add 4 noded plates. So we click on display whole structure. So we have modeled plates on the terrace of this framed structure, and after that we can also add surface here. So what we need to do is that we need to select beams cursor again go to view from plus Z, select all these beams here, go to view and selected objects only, go to view from plus Y, that is plus plan view, and we can left click on add surface. So similarly we can draw a surface also. The only difference between modeling plates and surface is that in plate, if we are modeling, the modeling stops at the 4th node, but if we are modeling surface, we need to again start and end at the same node number. So we press surface cursor here and then select these surfaces. So we have now modeled 5 number of surfaces, that is 1, surface number 1, surface number 2, surface number 3. It is showing that A is at 40, that is this node number, B is at 41, that is this node number, C is at 42. Similarly, it is showing all the 6 number of nodes. And here we can see that it is 4 noded surface, so it is showing 4 number of nodes. And after that we can go to display whole structure. So we have learned how to add the surface also. After that it is showing that we can add 8 noded solids also. So how we can do that? We need to select these points here. So now we have 8 number of nodes, that is 1, 2, 3, 4, 5, 6 and 7 and 8. Go to view selected objects only. After that left click on add 8 noded solids. So you need to take care of how we are modeling the solids. Basically what I'm trying to say is that left click on undo here. What I'm trying to say here is that we need to follow the either clockwise pattern for both the planes or anti-clockwise pattern. Right now I'm following the clockwise pattern. So after I am finished here drawing this surface, I won't start at this surface. I won't start at this node. I will start at this node only. So again we go to this these 4 nodes here, and then we have modeled the completely good solid surface. Otherwise what will happen if we do that is that we did the clockwise here and then we did the anti-clockwise here. So here you can see that it is something is not correct here. So we select the solids cursor here and then go to 3D rendered view. So here we can see that the surface solid that we have modeled is not correct. And if we do the modeling again correctly, select the solids cursor here. So here we can see that this is a perfect solid model. So we go to display whole structure again. So now we have learned how to model the beams, how to model the 4 noded plates, surface, and 8 noded solids. So these 4 options are also used while modeling, that is snap node and beam, insert node, generate surface meshing, and insert openings in the surface. So meshing is also a very important part while we are doing the FEM analysis, that we will discuss in the separate lectures. So after that we can go with translation and repeat, circular repeat, generate mirror option, and generate rotate option. So what basically it means is that if we see the height of this floor, it is approximately 5 meters. So what if we want to repeat the whole structure in the global y-axis 5 times? So we left click on translation and repeat. We select the global direction as y. Number of steps is 1, 2, 3, 4, and 5. Default step spacing we can select it as 5 meter only. And we left click on OK. So now we can see that this 1, 2, 3, 4, and 5 times the structure is repeated. So to make the things clear, we can press Shift plus B and Shift plus N and Shift plus K. So now we can see that we have translation and repeat the structure along y-axis. Similarly, if we want to translation and repeat the structure along x-axis, so what we can do is that we need to go to plan view, press beams cursor here, and select all these beams here. There's one more thing that I'd like to add here, that while doing translation repeat along this axis, we want to select these beams. Otherwise this beam will be copied on this beam and there will be duplicate beams. So to avoid that, we select these beams only. To select translation repeat x, default step spacing is 6 meters, number of steps as let us say 3, and axis is x-axis only. So now we have translation repeat the whole structure along x-axis 3 times with the spacing of 6 meters. So these are the options that like reduce our work a lot. That is, we can just simply translation and repeat. We can either, and one more thing that I'd like to add here is that there is this option of circular repeat also. So circular repeat is the option that is somewhat tricky in the beginning. That is, it requires a lot of practice to perfectly do this circular repeat. So what we can do here is that we can draw an orphan beam here, that is let us say 15, and we can select the circular repeat for this beam only, and we can select axis of rotation as y, that is the beam will be rotated about this axis only through node this. So we select this option here and then select on node, so it will select node number 242. If you press Shift plus N, here we can see that this 242 is the number that is automatically available here, and total angle as 360, number of steps let us say 6, that is 60 degree, 6 into 60 equal to 360, and we can select link steps also. So here we can see that we have repeated this beam, that is 1, 2, 3, 4, 5, and 6, and the angle between this line and this line is 60 degree. So 60, 120, 180, 240, 300, and 360. And as we have selected link steps option, so that is why this beam is modeled here. Otherwise, press Ctrl plus Z on your keyboard to undo this, and then again circular repeat here. Again node through 242. If we don't select this option, so here we can see that these beams are not showing here. So this is the way with which we can either do the translation repeat or circular repeat. And mirror is also a very useful option for the modeling. So how basically mirror is the option with which we can just model a structure or a part of the structure in a mirrored manner. So that we can see with the help of practical example. So let us say if we want to mirror these beams about this plane. So what we can do is that left click on generate mirror. Here we can see that it is showing the preview example, that is plane of mirror. So what we can do here is that our mirror plane is YZ. You need to be careful here because most of the newbie structural engineers are not sure about which option to select here. So you need to analyze in your mind, that is why I am selecting YZ, because the global axis is showing like this, and we are trying to mirror these beams about this plane. So selecting mirror plane as YZ, plane position as this, and either we can move or either we can copy, and left click on OK. So here we can see that all the beams are now mirrored here. And one more thing that I'd like to add here is that if we do the left click on generate mirror option, mirror plane as YZ, node on this plane, and move here. So here we can see that all the beams are deleted here, and all these beams are now modeled here. So this is the option with which we can reduce our work a lot. And this is also option of generate rotate. So this is somewhat like the array option that is available in the AutoCAD software, so that you can practice by your own. But most of the widely used option that I do in my modeling are these options only, that is generate mirror, circular repeat, and translation repeat. So now we have studied all these options here, and this is the option of select toolbar, that is nodes cursor. It will select only nodes. It will not select the beams, or it will not select the plates, or it will not select the solids. Similarly, beam cursor will only select the beams here. Plates cursor will only select the plates here. So here we can see that only plates are selected. And surface cursor, only surface shall be selected. Solids cursor, only solid shall be selected. And this is the option with which everything shall be selected, that is geometry cursor. So if at any stage you want to delete the whole structure, including plates, beams, solids, surfaces, or you want to select those options for either repeating or whatever you want, you need to go ahead with geometry cursor only. So this is the select toolbars options that are available here. And after that, the whole GPS of the software is right here. That is, whenever we want to open the general options, that is material, if we want to import the material, load and definitions, support, specification, properties, we need to go to general. Geometry is used to either model beams, that is beams option, plate option, surface option, solid option, parametric option. Parametric are used to add the mesh surfaces. Composite deck are used when we are modeling the composite steel structure floors. So here we can left click on composite deck and create new deck by selecting the beams. And this is the physical modeling options. So setup is like job, that is we can enter the job number, we can enter the engineer name, checker name, and approver name, or we can add the comments for our understanding. So let us, for example, if you want to add plate added, solid added, surface added, we studied about the surface options, mirror options, etc. So whatever you want to check, we can enter here. And analysis options are basically divided into three parts, that is analysis. We can either enter perform analysis, p delta analysis, nonlinear analysis, pushover analysis, buckling analysis, imperfection analysis, whatever you want to have. And preprint is the data which will be available in the output file, and this is the basically joint coordinates, member information, member property. This is like somewhat similar to the table option that is available here. And post-print data is also widely used. The most important option is the load list option only. that we will study in the separate lectures. So after that we can press the design options, that is the software can do design for steel, concrete, timber, aluminium and shear walls, that is 5 different type of materials. So we can select the current code as either as ASTO, or we can go ahead with this AS4100, whatever the depends upon the license that you have. And timber, basically you need to notice here that for steel only steel codes will be shown, for concrete only concrete codes will be shown, for timber only timber codes will be shown, for aluminium and for shear wall only 3 codes are available. So if you remember, we have selected the default code of concrete as ACI only, so that is what is showing here. And as I had told you earlier also, that all the different codes will also be available, so there we can see all those codes. For example, DIN German code, and BS British standards, AS 3300 Australian standard for concrete design, IS 456 India standard, IS 13920 the concrete code for ductile detailing, SNIP Russian code. So similarly we can see the steel codes also, that is AISC, castellated, LRFT. These are the nuclear codes, and 690 is the nuclear code option. And ASME, American Society of Mechanical Engineers, BS 5950, CSA S1614 is the latest standard of Canadian structural steel design. DIN is again a German code, EN is a Euro code, EN3, EC3 we call it in short form. 800 IS 800 is Indian standard for limit state design, working stress design. 801 is for cold form, and Mexican LRFD. And similarly we can see the SNIP, that is Russian standards, SP16 also. So the purpose of this lecture was not to input all the data into your mind. The purpose of these introduction lecture was just to make you familiar with what exactly are the options that are available in the different parts of the softwares. And I must say that I have not covered all the options or all the functioning of the software. We have just completed only up to I think 50 to 60%. So in this lecture series we will learn about the STAAD editor. See, editor is an option which gives us to program a structure. What I mean here is that either we can model a structure with the help of graphical user interface, or in the conventional times when the STAAD was introduced 10 to 15 years back, people used to model the structure with the help of editor only. So first of all we need to select space here, and then we can enter the file name, let us say editor example, and then accordingly we will save the location here also, and we select the units as meter and kilonewton. Next, after that we click on open STAAD editor option. So we left click on finish here. So this is the STAAD editor option. And one more thing I'd like to add here is that if you have not selected the legacy STAAD editor in the configuration option, this editor might be different. So overall the functioning is same, but only the look is different. So first of all, after the input width is 79, we need to enter units as meter and kilonewton. After that we need to enter the joint coordinates. It's like we are instructing the editor that in the next line the coordinates are entered. First of all we enter the name of the coordinate, that is node number 1, and then we enter its coordinates, that is 0, 0 and 0. So this is the node number, that is 1, and the coordinate along x is 0, along y is 0 and z is 0. After that we put a semicolon here, and then again we repeat the procedure. Let us say joint number 2. If we want it as offset of 4 meter along the x, so we enter x as 4, y as 0 and z as 0. Similarly, if we want to enter joint number 3, let us say we enter it as 8, 0 and 0. So you can press Ctrl and S on your keyboard, or either we can go to File and Save option here. So we close it here. You will see that only one node is visible here. So what we can do is that we can press Shift and K option on your keyboard. So here you can see that this is the joint number 1, joint number 2, and joint number 3. And if we want to check the distance, we can left click on display node to node distance here. This is 4 meter and this is 4 meter. So if we repeat the joint coordinates in the graphical user interface option, that is this option, either we can go for translation and repeat and press Z, default step spacing as 4. So left click on OK. So this is the node number 4, node number 5, and node number 6. Please press Shift plus N on your keyboard. So this is the joint number 4. So the coordinate of the joint number 4 should be x0, y0, and z4. So we go to editor again. So here we will see that for joint number 4, x0, y0, and z4. And the joint number is joint number 4. Similarly, it has automatically calculated the coordinate of joint number 5 and joint number 6. So this is an example of a joint coordinates. That is, whatever we will enter the data here, it will automatically be imported here. Or whatever we do the changes here, it will automatically be done in the editor file. In the similar manner, we have entered the joint coordinates. In the similar manner, we can also enter the members incidences also. So in the language of STAAD editor, it is called as member incidence. So in the member incidence, what we need to do is that we need to name the beam, that is beam number 1. That shall be between joint number 1 and joint number 2. So what we enter is 1, 1, and 2. So it means that beam number 1 is between the joint coordinate number 1 and joint coordinate number 2. So here we can see that automatically a beam is drawn, and press Shift plus B on your keyboard. So here we can see that the beam number 1 is between joint number 1 and joint number 2. Similarly, if we want to draw a beam between joint number 2 and joint number 3, let us say we name it as beam number 2. So we go to the editor again and we put a semicolon here. So we enter it as 2, 2, and 3. So we modeled a beam number 2 between joint coordinates number 2 and 3. And after that, if we model a beam from joint number 1 to joint number 4, STAAD is automatically named as beam number 3. So we go back to the editor and we should expect 3, 1, and 4 command. So here we can see that 3, 1, and 4 command is automatically inputted by the software itself. So similarly, we can draw a beam from between 2 and 5, and between 3 and 6, between 4 and 5, and between 5 and 6. So after that, here we can see that it has automatically prepared its own syntax file for the member incidences. So this is a simple example of how we can model a structure in the STAAD editor also. See, editor is something that makes our work very, very easy. And I must say that this editor thing is there in the ETAP software also. It is there in the Midas Gen software also. It is there in the Midas Civil software also. And most of the commercial structural design softwares that are being used by the engineers worldwide have this editor file option in one way or the other. That is, sometimes it do happens that most of the actions, if we perform it with the help of graphical user interface, takes a lots and lots of time. So editor is there to make our work easier. Not only this modeling thing will be incorporated in the STAAD editor, whatever loads we will enter, whatever supports we will enter, whatever specifications we will enter, each and everything can be referred from the STAAD editor. And if required, either we can delete a member, for example, do any modification from the graphical user interface. For example, let us say we deleted the beam number 7 here. So in the editor also, beam number 7 will automatically get deleted. So here we can see that the beam number 1, 2, 3, 4, 5 and 6 are only available. So this is the advantage of using the editor file. And the each and every process or each and every model that we will make, so simultaneously I will teach you what exactly is the syntax, or what exactly is the way with which we can incorporate each and everything in the editor. That is, for example, if we enter the support here as fixed, let us say, so we create and fixed option here, we select the join number here and left click on assign. So when we go to the editor file, in join number 5 there should be a fixed support. So supports, this is the syntax that now we are entering the supports, and join number 5 it is fixed. So in the further lectures we will study much more about this editor option also. In this lecture we will learn about the translational repeat command and circular repeat command. So before studying these commands, we need to go to geometry, snap, grid and node, and beam. Here snap, node and beam window will appear. In this we need to left click on create option, and here we need to select radial. As in this example, we will learn how to do the circular repeat also. So we can make a circular grid arrangement, and we can see here that this is the plane, that is XY plane, and here you can see that this is XZ plane. So here we can select it as plane as XZ and angle of plane as YY, that is vertical profile. And here there are various options, that is grid origin. If we want to the grid at origin point or anywhere else, then we can select it as 0, 0 and 0 if we want this point as origin. And start angle 0. Sweep, that is how much repetition it will take. Here we can select 360 only. Radius 1 as 0 and radius 2. Let us say if we want to model a circular tank of 6 meter diameter, so here we can select it as 3 meter. That is, if I am saying radius diameter as 6 meter, then its radius shall be 3 meter only. And base, number of repetition, and this is also a bay. Here we can study, left click on OK, and we need to switch on here this and switch off this. So here what I'm trying to say here is that left click on edit again. So here we can see that 1, 2, 3, 4, 5, 6, 7 and 8. So this is the 8 number of bays along this profile, and total number of other bays are 10. That is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. That is the division along the perimeter of the circular grids. And if we want to repeat or if we want to increase them, that is see, so now the number of bays are 14, and similarly we can, now the number of bays have been increased to 20. And if we want to change this distance also, that is, here you can see that the total radius is 3 meter. That is, from this point to this point the distance is 3 meter. And if we want to increase or decrease that, here you can see that now the number of bays are 6, that is 1, 2, 3, 4, 5 and 6, and this is the distance that is being shown here. That is, the radius of this circle is 0.5, this circle is 1 meter, this circle is 1.5. Similarly, the radius of this circle is 3 meter. And if we want to increase the radius also, let us say 6 meter, so this 3 will become to 6 and this 0.5 will be changed to 1. So here you can see that this is now 6 and this is changed to 1. So keeping the same dimensions here, now we have idealized a normal circular grid, and then we can left click on OK. And now we need to draw, suppose we want to do the FEM analysis of this circular tank. So what we need to do is that we need to model the plates. So before modeling the plates, what we need to do is that we can left click on add beam and left click on this option here, and left click here, and then again left click here. So by doing this, we have instructed the STAAD Pro softwares that there are we need these nodes. And why we need these nodes? So that we can model a plate element. So press Shift plus N on your keyboard. So here you can see that the software has generated various nodes here also. So geometry, snap grid node and beams. So we come back to this view, and then we can left click on add 4 noded plates. So number 1 plate, number 2, 3, 4, 5 and 6. And here you can see that 4 noded plate is not possible here, as there are only 3 number of nodes. So what we need to do is that we need to go to geometry, add plate, and left click on triangle here. So we can add a triangular plate here also. And as we don't need the beams, so we can select all the beams here and then press delete on your keyboard and then just delete them. So press Shift plus N again, and see the number of plates, we can press Shift plus P on your keyboard. So these are the number of plates, at 13, 14, 15, 16, 17 and 18 here. And after that, if we want to select the plates here, so we need to select the plates cursor here. And we have selected all the plates, and now we want to do the circular repetition of these plates. And here, as we can see that we have 20 number of bays. So we need to repeat this arrangement 20 times. So we can left click on circular repeat here. Axis of rotation shall be Y only, because we want to just imagine you are standing here along the Y axis. So while standing here, you want this whole arrangement to be circular repeated. So we can select the number of steps as 20. Through node, as you are standing here, so you need to left click here and then just left click on OK. So here we can see that we have correctly did the circular repetition of this plate arrangement. And one more thing I like to add here, that is, if we are doing the circular repetition in a wrong manner, for example, let us say we do the same thing again through this axis of rotation as Y. Number of steps, let us say we select it as 19 and then left click on OK. So here you can see that if we are selecting 19, then there is a mild gap between these plates. That is, press Shift plus K on your keyboard to see that there are 2 number of nodes here. So it is an incorrect arrangement or an incorrect circular repetition. So undoing this effect and then selecting all the plates again to correct the circular repetition. Initially doing these type of things when you're first to the software may be confusing to you, especially this mirror option and translation and repeat and circular repeat option. But you need to practice to be more proficient in these commands. So now we have modeled let us say the foundation of this whole circular tank. And now let us say we want to make a tank from this point to this point only, that is from 5 meter. So now translation and repeat option will help us. How it will help us? Select these 2 nodes and then press translation and repeat. Let us say the height of the tank is 4 meter, and what we need to do is that we can press, let us say 0.5 default step spacing, and number of steps is 8. That is 8 into 0.5 is 4 meter. That is our desirable height of the tank. And global direction is Y. That is this direction. So left click on OK. And there's one mistake that we have done. We need to press the link steps also. That is default step spacing again as 0.5, number of steps as 8. Global direction as Y. So with this option, what we can easily do is that we can just model the plate elements here. Although link steps option was not a compulsion to do, but it becomes very easier for you to find this perfect alignment for modeling the plates. Link steps option just help us in like saving us lots and lots of time by automatically modeling the beams along all the nodes. So we select all the beams here, and now again what we need to do is that we need to select the plates cursor here, go to this view from +Z, and we need to again do the circular repetition. So what we need to do is that we need to go to circular repeat option, axis of rotation is Y, total angle is 360 and number of steps is 20, and through node origin. Just imagine you are standing here, and we don't now need the link steps option as it is a plate, not a node. So now we can see that we have modeled a circular tank with foundation on the bottom. And one more thing I'd like to add here, that is when we need to go to general and property. Here we can see the thickness option. This thickness option is used to assign a plate element thickness. That is, let us say the wall of the tank is approximately 0.45 meter. So we select it as 0.45. And we need to select the plates cursor here, and we need to select all the plates of the tank. So here we can see that we have assigned the 450 mm thickness to all the walls, and let us say the thickness of the foundation is 0.75. So we enter 0.75 here, and material as concrete. Left click on close, go to this view from +Z option and select all the plates here. And when we need to see whether we have modeled it correctly or not, we need to go to 3D rendered view option. So here we can see that this is the foundation, that is 750 mm thickness, and this is the wall of the tank, that is 450 mm thickness. So with this option, we have studied how to do the translational repeat and how to do the circular repetition. See, most of the time if we are modeling the tank foundations and the tank walls, we need to do the finite element method analysis. So with that, we can easily check what are the stresses and what are the bending moment along both the X direction as well as along the Y direction. So the purpose of this exercise was only to make you familiar to this translation repeat and circular repeat option. In the separate lecture, we will do the advanced analysis of this whole tank foundation and tank walls.